Memory management. So which are the basic? First one is your fixed partition. Second one is your dynamic partition. Third one is a simple paging, and last one is a simple segmentation. So these are the methods of memory management. So we'll go for the first one, fixed partition. Fixed partition means what? Equal size. Equal size partition. Dynamic partition means what? Variable size partition. Then your studies is paging and segmentation. Same. Paging means what? Page size. Suppose you are going for Windows, your page size is how much? 4 KB. Likewise, how to do the paging? Conversion of pages to the physical organization or physical storage of that page, pages. And segment is a collection of segments. So we'll go for the first one. Simple fixed partition. First one is your fixed partition. So what happens in this fixed partition? Same size blocks. So partition main memory into the set of non-overlapping regions called as partition of same size. Partition can be equal or unequal size. What happens here now? Partition. So how many overlapping region called partition? So operating system 8 MB. Then all are the equal size partition. 8 MB, 8 MB, 8, 8. So this is a fixed partition size. Then here also how much? Fixed size. Suppose 2 MB, then 4 MB, 6 MB. It is not variable. 8 MB, 8, 12, 16, 32. This is unequal size partition. It is a fixed partition. Means what happens here? Whichever size, suppose you require the 5 MB of your memory size. Now what will happen? If you want to store the 5 MB, here you have to store it in the 6 MB. Okay, 1 MB will be the fragmentation. 1 MB will be the wastage. So this will what happens in this fixed partition. There will be the internal fragmentation. Okay, what is internal fragmentation? Suppose XYZ is a program whose size is 5 MB. Okay, and here all it is what? 2 MB, 4 MB, 6 MB. So here in 6 MB your program will be saved. So 1 MB will be what? Remaining here. 1 MB will be remaining. So that is what? Internal fragmentation. Okay, again same, whichever size will be unused, whichever size will be unused, we are combining that. That is called as a compaction. Okay, that is called as a compaction. Suppose here now you are here 1 MB there, again second program comes, that size is 7 MB, again 1 MB. So what? This 1 MB and this 1 MB. So we are having 2 MB. So this is called, this process of combining the unused memory is called as a compaction in operating system. So I've got the fixed partition, equal size partition. It may be the same size or it may be the unequal size. So this is called as a fixed partition. So any process whose size is less than or equal to the partition size can be loaded into that portion. I explain you that what? If it is equal size, suppose your program or the process is of 4 MB, then we can place it into the 4 MB. But if it is a 3 MB, we cannot place into the MB. So we should place into the 4 MB. So there will be what? 1 MB wastage. So if all partitions are occupied, the operating system can swap a process out of the portion. A program may be too large to fit in a partition. The programmer must then design the program with overlays. Some part will be in a second partition. That is called as a overlays. When the module needed is not present, the user program must load that module into the program partition, overlaying whatever programs or data are there. So whichever part we want to execute. Suppose your program is of 9 MB now. So we cannot fit into the 8 MB. So 1 MB will be in another partition. Okay, 2 MB partition, that 1 MB will be there. So that is what 1 MB is a overlay. We call that process of 9 MB execute. So 8 MB of that partition, 1 MB of overlay will be called for the execution. There is what disadvantage is what there is an internal fragmentation. So here it comes. Main memory use is inefficient. Any program, no matter how small, occupies entire portion. This is called the internal fragmentation. That is called as a internal fragmentation. Have you got this? Main memory use is inefficient. Any program, no matter how small, occupies an entire partition. So here, suppose your program is of 7 MB. Here it will occupy this 8 MB and 1 MB will be here remaining. So that is a internal fragmentation. That is called as a internal fragmentation. Unequal size partition lessons that problems must कौन करता है ये? Unequal size partition lessons this problem must there will be remains. So equal size partition was used in early IBM OS multi-program with fixed number of tasks. In this OS they were IBM PCs they were using fixed size partition. Then placement algorithm with partition means what? How to place that program or the job into that partition. So there are some algorithm: equal size partition, unequal size partition. Okay, there are two types: placement algorithm with partition. Unequal size partition use of multiple queues. Now here 1 MB, 2 MB, 4 MB, 8 MB, 8 MB, 16 MB, 32 MB, whatever may be. This is a size of fixed partition. Assign each process to the smallest partition within which it is fit. So here, if it is a 0.5 MB process, so this will be in a 2 MB here. So assign each process to the smallest partition within which it will be fit. So there will what? Less internal fragmentation. The queue for each partition size. So new process comes. So whatever we are specifying this queue, and based on this partition, that process will be placed into this queue. Tries to minimize internal fragmentation. Okay, means what happens? Suppose here is this 32 MB and your program is of 28 MB. Okay, so how many here it will have wastage? 4 MB wastage. So if you are having this type of queue, we can place where there will be internal fragmentation will be less. Instead of wastage of 4 MB, there will be wastage of 2 MB. Some queues, so what is disadvantage of this one? Unequal size partition. Some queues will be empty if no process within the size range is present. Suppose your process is not of any process of 2 MB. So this will be empty partition. Some queue will be empty. Then unequal size partition, use of single queue. Use of single queue only and place that in that partition. Whenever it times to load a process into main memory, the smallest available partition that will be hold the process is selected. Increase the level of multi-programming at the expense of internal fragmentation. So more internal fragmentation will be here in this also. Okay, now we'll go for the second type, that is your dynamic partition. So dynamic partitions are variable length number. Each process is allocated exactly as much as memory as it's required. So if the program is of 5 MB, 5 MB will be allocated, 7 MB, 7 MB will be allocated. Eventually, holes are formed in the main memory, that is called as a external fragmentation. holes are formed in a main memory, that is called as a external fragmentation. Must use compaction to shift processes so that they are contiguous and all three memories in a one block. Now, what is the use of compaction? Means you are allocated. Yeah, allocated memory. There are the small holes in external fragmentation, in dynamic partition also. If your free memory is 5 MB, but it is not continuous. So what we have to do? We have to combine all that processes, all that memory, and create a one whole memory. That is called as a compaction. Okay, it is used in a IBM multi-programming with variable number of tasks. So this dynamic partition. So dynamic partition. So this is a 128 KB is required by OS, and you are having 896 KB here. Now your process is of 320K. So 320K will be allocated process 1. Then process 2 is of 224K. It will be allocated here at much size. So this is now remaining. Again, 288K is for process 3. So that will be allocated here. Now this 64 KB is used. 64 KB is remaining. The whole of 64 KB is left after loading 3 processes. Not enough room for the another process. Okay. Now this 64 KB, this is external fragment. Okay. What was the internal fragmentation? It here, then here. Whatever may be. Suppose your process is of 320 KB and you are having 400 KB process memory size. So 80 will be your internal fragmentation. This is what external fragmentation. Internal within your memory only. Eventually, each process is blocked. Though swap out process 2 to bring into the process 4. So here 64 KB is what? Not enough. So what we have to do here? If you want to another process, want to enter, then it will swap. Process P2 will be swap out and process P4 will be swapping. That is called as a swapping. Another whole of 96 is created. So this we have swap here. Okay, this process is now out. Now this process P4 comes. It is of 128 KB. Now here how much remaining? It is 96K, and this is your 64K. Okay. P4 is in, P2 is out. Swap out, this is swap in. Now again, which process come? P1 is out. So it will release how much memory? 320K. Swap out is your process 1. Now process 2 again you want to execute. So process 2 is of 22K, 224K. So it will allocate this memory. Now how many holes are there? This 96K, 96K and 64K. So this is what? Now external fragmentation. This is called as a external fragmentation. Now this memory is available. How much? 96, 96 and 64. How much? 200 something. Now if any process come of 200. So how much it is? 256 is free now. 96K, 96K and 64K. 96, that is 256K memory is free, but it is not continuous. So we have to do the compaction. We have to combine this 96, 96 and 64. Okay. This process is called as a compaction. So it will allocate the last portion. It will allocate this last portion. And then if any process come to 56K, that will be allocated to 64K. That is called as a compaction. Then algorithm, placement algorithm for dynamic partition. So there were two, unequal size and equal size queue for fixed partition. Now in the dynamic partition, there are 3 algorithms. There are 4 actually, 4 algorithms for dynamic partition. Placement algorithms for dynamic used to decide which free blocks to allocate to the process. So this algorithm is used for which process should be allocated into the which block. To reduce the use of compaction. What is goal of this placement algorithm dynamic partition? To reduce the goal of compaction. Means what happens here? Suppose you are having 4 MB, allocate that 4 MB. Okay, so there will be no internal fragmentation, no need of compaction, which is time consuming. So which are the algorithms, possible algorithms? First fit, best fit, first fit, next fit, and last one is a worst fit. So these are the 4 algorithms. placement algorithm, dynamic partition placement algorithms. So there are 4: best fit, first fit, next fit, last one is a worst fit. Now what happens in first one? Best fit. Choose the smallest node. Best means what? There will be minimum compaction or minimum internal fragmentation. So we have to find the best fit in this one. Best hole for that process or best memory that will give minimum hole with that process, that is called as a best fit. Then first fit is choose the first hole from the beginning. That is called as the first fit. We'll see the example. First fit, choose the first hole from the beginning. Starting with the first process, means starting with this 4K. Find the first hole or the first memory which will allocate it to that process, that is called as a first fit. Next fit, choose first hole from the last placement. Suppose you are placed here, first fit मध्ये. Then from here we should go remaining part. That is called as a next fit. And last one is your worst fit. So what happens in worst fit? Find the largest hole. Find the largest hole of that process. That is called as a worst fit. Okay. I got this one: best fit, next fit, worst fit, and first fit. आज लक्षात आलं का हे? Yes or no? So we'll see the example. Wait for 5 minutes. Now listen here. We'll see the example. Okay. दिसतंय सगळ्यांना? So what is here given now? So this is your process and this is your memory size. Dynamic partition memory size. What is P1 size? It is how much? 50 MB. P2 it is 250 MB. P3 it is 30 MB, P4 it is 570 MB, and P5 it is 400 MB. And memory size partition given how much? 100 MB, 300 MB, 150 MB, 700 MB, and last one is a 500 MB. So what we have to do? Dynamic partition. Now listen here. So there are how much algorithm? 4 algorithms. First one is a first fit. Second one is a best fit. Third one is your next fit, and last one is your worst fit. So these are the 4 algorithms: first fit, next fit, best fit, and worst fit. So we have to allocate this process to this memory size. Now first one is your 100 MB, 300 MB, 150 MB, 700 MB, and last one is your 500 MB. This is given. Now we'll go for the best fit. First of all, we'll go for the best fit. So find the best hole. So which is for 50 MB P1. Now we'll suppose this is 100, 300, 150, 700, and 500. Okay. This is the size of memory. Now you have to allocate this process to this using these 4 algorithms. Okay. So first one is your, we'll go for the best fit. Find the perfect memory or the hole for that process. So that is called as a first fit, best fit. So 50 MB will be allocated in which block? Here. P1 be allocated into, because what happens here, wastage is how much? 50 MB. Here it will how much? 100 MB. Here it will more. So P1 will allocated in the 100 MB block size. Then 250 will be allocated in best, which is the best one? 250 here. 300. Okay. Then P3. So P3, which is the next block? All P3. So here will be P3. Now P4, 570 MB. So it will be here P4. And P5, 400 MB. So here will be the P5. So this is which one? Best fit. Okay. This is called as a best fit. Now again we'll go for the worst fit. Suppose now. Worst one is simple. Worst fit. Find the largest hole. So 50 MB will be here. Then next one is 250 MB will be here. Here. Then 30 MB P3. Then 570 P4 and P5 will not be allocated. Will not be allocated. I got this one worst fit. दोन लक्षात आले का? Best fit and worst fit. Yes or no? Yes or no? Then next one is your first fit. Find the first one. Which come first, that we have to allocate. So again here 100, 300, 150, 700, and last one is your 500. So first process P1, which process here comes first? Find the first hole that will be allocated. So P1 here. Okay. Then first P2 here, P3 here, P4 here, and P5 the same as a best fit only based on an example. So this is a first fit. Whichever it comes first, that is called as a first fit. Now next fit. So again same next fit. Now what happens in next fit? I'll explain you before this example. Now suppose here it is block is allocated. Suppose here P1 is allocated. Okay. Now we have to find after this. This is called as a next P. हा ब्लॉक रिकामा असला अलोकेट होत असेल तरी तो करायचा नाही. आपण एखादा पहिला हा इथं अलोकेट झालाय त्याच्यानंतरचा ब्लॉक अलोकेट करायचा. नेक्स्ट म्हणजे तुमचा शेवटचा झाला पहिलाच प्रोसेस तुमच्या शेवटच्या ब्लॉक मध्ये झाला असेल in the last field. So remaining will be not allocated. That is called as a next field. I got this one next field. And here example same in because simple example घेतलं होतं. This will be next field will be same as your base field and first field. Okay. I got the meaning of next field. Suppose your P1 is allocated in the last block. Next field will be after that only. So no process will be allocated. That is called as a next field. Okay. I got this one. We'll stop here. Next will be your, so this is a placement algorithm. Bench speed, next speed, watch speed, and first speed. These are the 4 algorithms. Now next point will be your buddy system. So that is a simple one, buddy system. So in next lecture we'll go for the buddy system. Okay. And then segmentation and paging in operating system. इथं काय अडचण आहे इथपर्यंत. So what we have covered today, best fit, worst fit, that is a dynamic partition algorithms, then fixed partition. So these 2 points we have covered in the today's lecture. Shall we stop here? Anyone is having any difficulty? Shall we stop here? So we'll stop here.